All right, so here's a problem that at first appears a little bit challenging because we're dealing with an absolute value. But once you realize that an absolute value function is actually made up of two linear functions, that simplifies things considerably. So let me try to make a graph here. Let me choose a different thickness there. So it's absolute value of x minus 1. So it's an absolute value function. And if you remember your transformations, then you know that we need to shift that curve to the right. So the original okay, so this was just for, oops, that was just for illustration. So I think at that point I can get rid of that. That was just to remind you of that transformation. But what we end up with then is simply um, two linear functions. Now it's piecewise. The domain doesn't run all the way, uh, but basically this is a function uh, y is equal to -1 times x minus 1. So it's a negative sloped line that is moved also to the right, and that refers to this side. So simply -1 x plus 1. And I think that coincides with this one over here. You could see the y-intercept. And then the other piece, let's go ahead and do that in blue. That is y equal slope of 1, and then x again moved to the right. So that's going to be 1x minus 1, which if I were to carry that over, even though it doesn't go that far, but you'll be able to see the minus 1. So you'll be able to confirm those for you. And so now we're able to work with these limits and say, all right, well, for part A, we have the limit of -1 x plus 1, and I'll actually note I was expecting this to coincide with this point. So now, recognizing that they don't, we are actually looking at, as we approach -2 from the left. So we're actually interested in just the left part of this curve. So we're actually just interested in this part and don't really care so much about this part. So I'm just gonna make it broken because we want to know what happens at -2. So there. All right, so we are approaching this point here. And so we're only using this equation. So as x approaches -2 from the left, well, the output, and I'm going to put this in parentheses, the output of f of -2 from the left is -1 times -2 plus 1, which is 2 plus 1, which is 3. So the output coming from this direction, approaching from the left, is 3. So 1, 2, 3 is the height. And since we're using the same equation, when I plug in a 2 from the right, we're using the same equation, but we're coming from the right. But it doesn't matter because we're using the same equation. So we plug in f of -2, and obviously we did it just a second ago, so we get the same exact answer. And I'm just double checking my work. I get 3. And so indeed, the limit is 3 on both sides. And that's how you do this, this problem that creates a bit of a challenge with the absolute value, but then we work it through. But you have to be careful with which x value we are approaching